What planet is this? I know what everybody says, okay? And I keep on telling them that is not a planet. That's a satellite. Okay? No, it is not the moon, but it sure looks like the moon. The moon is a satellite, it's called. Now, this is a planet that goes around a star. A satellite goes around another planet. Okay, it looks exactly like the moon, and the reason is that it is the only planet that we have in our solar system that does not have an atmosphere. So these are all the impacts from the beginning of its evolution. And I just read recently that Mercury has more impacts than our own sun. Now, we had some missions going to Mercury, and they use a lot of gravity assist. And it took, the first mission that finally made it here was 7 years to get there. They did a gravity assist around the Earth. It gave three gravity assists around Venus and 1 gravity assist around Mercury to be able to land the rover on Mercury. Now, Mercury, you would think, does not have any water, but it's been estimated that it has significantly a lot of water in some of the impact craters that have never had sunlight on them. They're estimating that it's 20 meters high of ice, water ice, that's on Mercury. It is a hot planet, but it is not as hot as Venus. We'll talk about in a minute. And it takes about 89 days to make 1 revolution around the sun. And one rotation of the planet, that is 1 day for it, is 58 Earth days. So it takes a long time to make 1 day. Okay, the next one I asked them, what planet is this? And a lot of them know that Mars is reddish. So most of the people say that this is Mars. Of course, this is Venus, and it is red like this because I believe the scientists put in different shades of red to show different heats. Now, Venus is interesting for a number of reasons. Number one, it has the most inactive volcanoes. It's got something like 1,500 inactive volcanoes. And what those volcanoes have done is put out of an atmosphere that's 98% carbon dioxide, and the rest is sulfur oxide. So when it rains sulfuric acid, so you don't want to be on this planet. And it is 800, it's about 850 degrees. So there's a lot of metals that will just melt on this planet. You take lead, tin, things like that will just melt, okay? Now in '85, the Russians had an unbelievable event happen. And that was they built a rover that landed on Venus, okay? And it collected data for 1 hour before it failed. The other thing that is difficult to design to on Venus is that the atmosphere is so thick and therefore so heavy. The pressure at the surface is exactly 98 times the pressure that we have on Earth. So it's an unbelievable amount of pressure that's on Venus. Now, everybody knows this planet, right? Yeah, it's our beautiful Earth. And 71% ocean, which is shown in the blue. The white, of course, is clouds. And 29% basically of rock and vegetation. Beautiful Earth. It has seasons because its axis of rotation is inclined 23.5 degrees to the ecliptic. And it has, of course, one moon, and we'll talk a little bit about the moon here in a minute. I do want to say one thing, and that is that we do have something like 350, 400 files of different things. And we do have a lot of the children that come in from the different classes, and the teachers want to study weather, tsunamis, volcanoes, earthquakes, whatever it is. We've got files about it. And I just want to give you an idea of just one of the files that we have. For example, this is the Earth at night. And as you can see, most of the light is on basically, well, there's a river there, or it's on, where are the transportation routes? The coast, I think that's Denver and Colorado Springs. Here's Hawaii, and we just have all type of files. The thing that I'm always amazed about is India. I can't believe the amount of electricity that India uses. And over here, you know what this wiggle is right here with all the lights on it. And that's, of course, the Nile. Everybody's living on the Nile over there. But let's go back to our own planet and its satellite, which is the moon. And talk about what we're going to be doing in the future. You know, for the last 10 years, that's all we've had in every magazine. Everything was, we're going to Mars, Mars, Mars. Well, last year, the Trump administration made the decision that we're going back to the moon by 2024. The first astronaut's going to be a woman astronaut that's going to land on the moon. So we're building what is going to be called the Lunar Gateway. And the contracts are out for it. We will start putting the gateway, which will be a spaceship, a docking station that's going to be around the moon. And we're going to start putting this together around the moon in 22. That's only 2 years from now. And it's going to be completed by 26. Now, all of the spacefaring nations on this planet have agreed that their docking mechanism will be standardized and will be able to dock into our station. The other thing that we're going to be designing is a lunar transfer vehicle. So it will go up to the docking station, transfer supplies, astronauts, and material on the moon will be transferred back. And there's a lot of things on the moon. So there's going to be a lot of exploration of the moon for rare materials. Hydrogen-3 is very important. The Chinese, for example, want to go to the moon for hydrogen-3. And it's very hard to find on the Earth because of the magnetic shield around there. It comes in through the solar wind. But anyway, a lot of it, they believe, is on the moon. And just a little bit of it, it's part of the fusion process of the sun. And a little bit of it, if you could complete the fusion, you have power, unbelievable amount of power, the power of the whole country, just a few number of grams, unbelievable. Our scientists have been working on trying to find a container to contain it. As you know, for fusion, you need over 4 million degrees. You know, they've thought of magnetic containers, all sorts of things. Have not been able to solve that problem. Okay. So we're going to have this new lunar gateway, and it is so much easier to launch from the gateway to be able to go into the solar system. You don't need as much fuel, basically. And that's assuming that we're having a propellant station. And we are going to develop developing liquid hydrogen and oxygen on the moon. Now, the European Space Agency said they're going to build a settlement on the moon. And 3 or 4 billionaires from Sunnyvale said that they're going to also build a settlement on the moon. So there's going to be a lot of activity. And you can't bring the entire raw material back with you. You're going to have to process it on the moon. So we're going to have processing on the moon, developing propellant, maintenance of the rockets, things like that. We'll probably have 4,000 or 5,000 people by the end of the century working on the moon. Okay, well let's look at what we have here. This is going to be our new rocket, which is called the SLS, Space Launch System. The shuttle was STS, Space Transportation System. And this is the rocket that will probably have its test flight next year. It keeps on getting pushed out. It'll be the largest rocket built. And that's the boosters. Once we're outside of the atmosphere, get rid of as much weight as you can. This is the second stage being built by the European Space Agency. And the command module will hold 4 to 6 astronauts, the Orion capsule. And the Europeans have sent the second stage, I think last July, to Denver, Colorado for integration tests going on there. But this will be a test flight next year with all of the hardware, but no crew yet. It'll be like Apollo 8, in which we went around the moon and came back and landed the command module in the ocean.